Good morning, students. Today we are going to see the topic of stereoisomerism. Those complexes which have same molecule and structural formula but differ in the arrangement of atoms or groups around the central metal atom are called as stereoisomers, and the phenomena is known as stereoisomerism. Stereoisomerism is basically of two types: geometrical isomerism, it is also known as cis-trans isomerism, and optical isomerism, also known as DL isomerism. So we are going to see in a detail what is the geometrical isomerism. The complex compounds which have the same ligands in the coordination sphere but a relative position of the ligands around the central metal atom is different is called as geometrical isomers, and phenomena is known as geometrical isomerism. In a given complex compounds, when the in a given complex when two similar ligands occupy the adjacent position to each other, then they are known as cis isomers. It is important. And if they occupy opposite position to each other, then they are called as trans isomer. Now we are going to see geometrical isomerism in a tetrahedral complexes. So basically, geometrical isomerism cannot be shown by tetrahedral complexes, as all the four ligands in this geometry have adjacent position to one another. Now we are going to see geometrical isomerism in a square planar complexes, and this is generally asked in the exams. So students should note that these two important points. When in your square planar complexes, similar ligands having 90-degree bond angle, then it is known as cis isomer. And when similar ligands have 180-degree bond angle with each other, then it is known as trans isomer. So we are going to see in detail. So square planar complexes of Ma4, Ma3b and MaB3 type does not show geometrical isomers because all the possible partial arrangement of four ligands around the central metal atom is the same. So basically, square planar complexes in which all ligands are same or three ligands atoms are same, that square planar complexes does not show geometrical isomers. Square planar complexes of Ma2B2 type. So in these complexes we see that ligand A have 2 molecules and ligand B have 2 molecules. So this type of square planar complexes exhibit geometrical isomerism. So just see the example of PTNH3 by 2 Cl2 complex. So in this complex we see that the bond angle in this arrangement of complex, we see that bond angle between similar ligands. So bond angle between this chlorine and this chlorine is 90 degree. So it is cis isomer. One can also see bond angle between this ammonia and this ammonia is also 90. So student can see the bond angle between similar ligand. If it is 90 degree, then it is cis isomer. Now just see second arrangement of same complex. So in this complex, we clear cut see that bond angle between this chlorine and this chlorine, it is of 180. They are oppositely placed. That's why it is trans isomer. Now we are going to see square planar complexes of Ma2BC type. So example of this type of complex is PdCl2Br(I2 minus). So in this complex we clear cut see that it have two chlorine atom. So just see the bond angle between your chloride or chlorine atom. So in this case, in this arrangement, bond angle between them is 90. That's why it is cis isomer. In this case, bond angle between two chlorine atoms, it is 180. That's why it is trans isomer. Now we are going to see square planar complexes of MABCD type. So complexes of this type exhibits in isomeric form. For example, PTNH3PyClBr exists in 3 isomer and it is shown here. These isomeric forms can be, so just see in this type of complexes you have to place one ligand fix. So I fix this amine ligand, its position is fixed in the space. It is written always here. So now in all cases your amine ligand is fixed. Now just change the position of atom or rotate the position of atom which is opposite to your amine. So in this case bromine is written here. So it is one different arrangement of this complex. Now in this case just see opposite to ammonia Cl is written. It is the second arrangement which is obtained for this complex, and in next case just rotate and write Py here. So this is the third arrangement of this complex, and they are all geometrical isomers of each other.